Greetings, everyone. It's 1 p.m. Eastern Time, and that means it's time to begin another CoCoRaHS Weather Talk webinar. Hello, I'm your host, Henry Regis, CoCoRaHS's National Coordinator. Along with me today is CoCoRaHS National Director, Nolan Duskin. We're coming to you live from the Colorado Climate Studio up against the Rocky Mountain foothills here in beautiful Fort Collins, Colorado. Each of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Today we bring you the third episode in our Weather Talk webinar series. We're glad to have you join us for what will be an educational, informative, and entertaining hour. Each of our Weather Talk episodes features a presentation by an in-the-know speaker from the fields of weather, climate, and hydrology. After our speaker's presentation, we open up the webinar for questions from our audience, which our guests will answer live on the air. Today's webinar is being recorded and will be available on the CoCoRaHS website on the Weather Talk series page for future viewing. So without further delay, let me introduce today's webinar. Our webinar today is titled, Who Uses Weather and Climate Data and How Do They Do It? And with us today is Steve Hilberg from Champaign, Illinois. Steve, longtime friend of the Colorado Climate Center, is a former director of the Midwest Regional Climate Center and current state coordinator of CoCoRaHS in Illinois. Welcome, Steve. It's great to have you with us today.
Thank you, Henry. I'm glad to be here and pass on some of the uses of weather and climate data that we see in our everyday work here at the Climate Center and around the country.
Steve, this is Nolan. Glad to have you today. By the way, those of you on the call, Steve and I have known each other for many, many years. And we're really delighted that he's part of the CoCoRaHS team in Illinois. But one of the most asked questions that I ever field here at CoCoRaHS headquarters from our volunteers is, does anyone actually use our data? There's this concern that when people do the observations that it's just going into a black hole. I have to keep assuring them time after time that, oh my, yes, the data are used. They're being used every day. And then the follow-up question is always, well, who uses our data and how do the data get used? And that's part of the reason that we scheduled this webinar fairly early on. For those of you on this webinar, we're not focusing just on CoCoRaHS data, however, but on climate data collected by the National Weather Service Cooperative Observer Network and other networks as well. So, Steve, I'll give it back to you.
All right, thanks, Nolan. Yeah, there's weather data is used all the time and constantly, and probably in the last 10 to 15 years, the growth in the use of the data has been exponential, partly because it's been so much more widely available. So what we're going to do here is talk about some of the uses, who uses it, and how they do use it. However, we're really only going to scratch the surface because we could probably talk for hours about this. There are countless examples of how weather and climate data are used, and a quick search on the internet using your favorite search engine would probably quickly consume hours of looking at examples of how weather and climate data are used. So as most everyone is aware, consciously or unconsciously, the weather does affect us all the time. We live in the weather. There's no escaping it. It surrounds us. We're in the atmosphere, and it affects us whether we live in Southern California or whether we live in Northern Maine. So my argument is in Southern California, you don't see much in the way of weather changes, and they're sort of used to a constant thing. But even in California and other mild places in the U.S., the weather changes quite a bit, and we do have to deal with extremes. And those extremes are what catch all the attention, of course, but that's not necessarily what we always have to be concerned about. And basically, all of us use the weather information in some respect. Every day, if you decide what you're going to wear based on what the forecast is, you're using weather information. In this case, you're using the forecast. But one of the things we're going to talk about is not so much just how forecasts are used, but how actual data, such as CoCoRaHS data, is used by people who need to use weather and climate data. So we take a look at the big picture and look at the economic cost of weather in the United States. A recent study that was published last summer estimates that up to $485 billion annually, that's $485 billion annually, is the cost of weather in the U.S. just from routine everyday weather. We're not talking about the big storms, the hurricanes, the massive snowstorms, the tornado outbreaks. Just the day-to-day changes in the weather. That is a big number. It equals about 3.5% of the 2008 GDP. So it is a significant portion of our economy, and in fact estimates are that about $1 trillion of the U.S. economy is weather sensitive. That's a big number. And it's not too hard to understand if you think about what the weather affects. Now, the most sensitive sectors that were found in this study, and this list might seem a little odd, that mining's at the top at 14% a year, but mining also includes drilling for oil, mining of coal. So there's a big energy component in that mining sector. Agriculture, obviously very big with 12%. Manufacturing also high. Then you lump finance, insurance, and retail 8%. And then we're talking about routine stuff. So we're not talking insurance. Typically deals with the catastrophic losses, but routine stuff, and then 8%. Utilities down around 6%. I'm not quite sure why utilities might be that low, but utilities have been dealing with weather for a long time, and they do have some built-in measures to deal with the weather on a more consistent basis, probably more so than any other sector right now. So $485 billion a year annually from routine everyday weather. $1 trillion in the U.S. economy is weather sensitive. And then we have what we call our billion-dollar weather disasters. The National Climatic Data Center has been tracking these for a number of years now. And this year you may have seen the press release or the news story back in December that so far we've accounted for $12 billion weather disasters last year. And at this point, and all the numbers aren't in yet, but that's totaling $52 billion in damages and then the loss of more than 1,000 lives. And these include everything from the drought in Texas and the Southwest to the big tornado outbreaks in Joplin and also in Alabama this past spring and summer. So, and also the hurricanes. So these add on top of the routine weather effects. So you're already talking about well over $500 billion, $500 billion annually in just those types of costs. So obviously the weather is hugely involved in a lot of the everyday activities that we take care of. Here's how the billion-dollar weather disasters distributed across the country in the last 31 years or so. And you can see the highest concentration is in the southeastern and southern United States. It's not too hard to figure out why. That part of the country is more susceptible to hurricanes. Obviously Katrina's in there, and most of the landfalling hurricanes tend to fall in there. The places to be, I guess, if you want to stay away from the big weather disasters is Wyoming, Michigan, and a lot of the New England states for whatever reason. But bottom line is no part of the U.S. is immune from the big weather disasters. And these, again, are the billion-dollar disasters. That doesn't take into account the many more smaller catastrophic events that might occur on a much more local level that don't quite cost as much money. So bottom line is the weather is big in our economy. There's no two ways about it. And the impact on the weather means that the government, businesses, and individuals have to have and do have a great interest in weather and climate data, both quality and quantity. And it's not just the weather forecast. It's weather forecast is good for future planning, but if you're looking at trends or the history or how your past performance has related to the weather, you need past weather data. You need historical weather data. You need records collected over the long term. So over the course of the next 30 minutes or so, we're going to look at some of the ways that weather and climate is used to guide decisions in a number of various sectors, both large and small. And I'll actually show some practical examples that you as a homeowner, or an individual, might be able to use in your life if you so desire. So impacts of weather and climate. There's a number of sectors that we typically deal with, but to be honest, it covers just about everything you can think of entertainment industry, sporting events. The list could be rather long, but we're going to talk mostly about these particular categories, and most of them are fairly obvious. We've got agriculture and energy, the environment, human health. That's not always, other than people think you go outside and you get a cold because it's cold outside, but there are human health connections to the weather that we have to pay attention to. Legal and insurance, transportation, and water resources. And again, this is all related to not necessarily the forecast, but looking at past weather data and trends. Now, there are many sources of weather and climate data. In fact, that has been growing incredibly over the last several years, 20 years probably. We, of course, have the hourly observations taken at the airports. You may have heard the acronym called ASOS, which is the Automated Surface Observation System. We have our U.S. Cooperative Observers, which are the National Weather Service volunteer observers throughout the country, about 11,000 of them. There are specialized networks around the country, such as the Remote Automatic Weather Stations, the RAWS network out west, which is used for fire weather support. SNOTEL, which if you live out west, you're very familiar with that probably, the Snowpack telemetry network, which is about 750 automated stations and about 1,200 manual stations. RAWS is about 2,200 stations. So those are specialized networks dedicated toward a specific purpose, but the data is available and people use that. AWDN is an agriculturally related network in the Central and High Plains, and there are actually a lot of these networks around the country now. And then there are state networks as well. One of the more famous ones you might, or infamous or famous, is the Oklahoma Mesonet. There's the New Jersey Weather and Climate Network, and a lot of states are developing their own networks for their own purposes. So there is a lot of data out there. In addition to those networks that might be state-supported or government-supported, we have CoCoRaHS. And I don't know what the current total is, but probably well over 10,000 participants, which is almost equal now to the co-op network. There's also what's called the Citizen Weather Observing Program, which actually collects weather data from home weather stations and brings that into a central location. The Weather Service does this and makes it available for people to look at and use. So a lot of weather data out there for people to use, but we'll take a look at how some of that is used. For example, here's one example, and this is a good example where CoCoRaHS data is used. River forecasting is a very important mission of the National Weather Service. Every office in the U.S. has, I believe, has a hydrologist on staff, and especially where there are river basins, and they help prepare and make river forecasts for the streams in their area. A considerable amount of data is used to create that forecast. There are river forecast centers in each of the Weather Service regions. They help collect this data and run models that do projections. Among the data they use are soil moisture measurements, current stream flow conditions, which come from the gauging stations run by the U.S. Geological Survey. A very important one is precipitation during the last 24 hours, the forecast precipitation. And then during the cold months, we have snowfall, snow depth, the snow water equivalent, remember SWE Mondays, and frost depth, which is basically how deep the ground is frozen. All those have implications on how water is going to either infiltrate into the ground or run off, and is critical for flood forecasting. Now, National Weather Service Cooperative Network is the first line of reports, but CoCoRaHS reports are being used now all the time in river forecasting, especially the reliable reports, the consistent, reliable reports that we get that come in every day. Radar precipitation estimates are also used, but you may have heard this before, but radar precipitation, while it's a nice thing to have, it does have its limitations, and that depends on where you are in the country, the season, and things like that. So ground truth from both from all the observers on the ground, both CoCoRaHS and Weather Service, really are used to help calibrate those estimations and adjust those radar estimates. And those are used in the river forecasting scenario. Now, when a river forecast is being generated, there are basins in each area. Now, this particular graphic shows river basins delineated by the red or pink, whatever you want to call it, lines on this map in northern Illinois, up near the Wisconsin border. If you see RFD in about the middle of the picture there, that's Rockford, Illinois. And then the black line across the top here is the Wisconsin-Illinois state line. So most of those are cooperative stations with the Weather Service, but there is a mix of CoCoRaHS locations in this map. And all the stations here now highlighted in yellow are CoCoRaHS stations. Currently we're seeing about 6 in Illinois here and then 1 in Wisconsin. So what they do with this is they calculate an aerial mean precipitation amount for each basin. So for example, in this basin here, where Rockford is, they would use stations here to calculate an aerial mean precipitation for this odd-shaped basin here. Now, if there's a value missing, then they estimate the precipitation at that point from surrounding stations. So it's really important that data is there to use. We don't want to use estimates unless we actually have to. Zero reports are just as important as non-zero reports, especially in cases like this, because missing does not mean no rain. So if a station is missing, the model doesn't assume no rain. It makes an estimate for that location. In the winter, a snow water equivalent is an important measurement from both the cooperative observers and from CoCoRaHS, because that tells us how much water is, so to speak, sitting on the ground in that snowpack. So zeros are very important. That's why we're constantly preaching, please report your zeros, because zeros are data. We have a little thing here we've been throwing around in Illinois lately called Be a Hero, Report Your Zeros. So you might hear that again. So they use that data, including these CoCoRaHS stations, to help calibrate their model and input precipitation. Now, the models are then used to generate river stage forecasts. And on this map, which you can see on any National Weather Service site, there are, if you go to their hydrology link, you can see charts like this for various rivers in their county warning areas. The blue line here is the observed values from the river stage gauge. And then these green points here are the forecast values. And basically this is out a week from, this is the day of the forecast. So this is a week out. So you can see here that on the Pecatonia River here in Illinois, things are fine right now, but within about 6 days, 6 to 7 days, the river is expected to rise above flood stage. So those observations, not just from the co-op network, but from CoCoRaHS, are used extensively now in river forecasting. And the hydrologists at the Weather Service look for these CoCoRaHS values all the time. Another use of weather and climate data, and again, this is where CoCoRaHS is involved, is in snowpack monitoring. Now, seasonal snow obviously impacts everything from water resources, which is especially important out west, to agriculture, transportation, and of course recreation, especially in the ski areas. Last year we had a lot of flooding related to snow melt throughout the country because we had a higher than normal snow cover. And the severity of flooding depends on a lot of factors, not just the snow accumulation, but how much moisture is in the soil, how fast the spring snow is melting, and how much rain you're getting on top of that snow. The National Weather Service, National Operational Hydrologic Remote Sensing Center, which we call NORISC, that's how we pronounce that acronym, in Chanhassen, Minnesota, produces a lot of these data products and services, and they have a really nifty website to look at for this. They're used for flood forecasting, water supply planning, the whole spectrum of uses for this kind of information. They use a system called SNODAS, the Snow Data Assimilation System, and it actually produces hourly estimates of snowpack, snowfall, snow cover, snow water equivalent, a whole variety of parameters. It uses all available snow-related data that they can get electronically. That includes regular weather observations from around the country, CoCoRaHS observations, and even supplemental observations from snow spotters around the country. They generate estimates of a variety of parameters, which you see listed there, and they do this every day, and then just tens of thousands of snow depth and snow water equivalent observations from all over the country. And you can look on their site and see many thousands of CoCoRaHS observations. They also use snow observations from satellite imagery, and occasionally when like last winter, when the snowpack was particularly heavy and they were concerned about flooding, like along the Red River of the North, between North Dakota and Minnesota, they will actually fly special airborne remote sensing flights to measure snow cover and snow depth and snow water content from aircraft, and include that in the models as well. Now, the neat thing about this is that the analysts actually look at the observations and compare them to the model, and when the differences between the two are significant, they can adjust the model, and this is called model assimilation, and it makes the model closer to reality. And it depends very much, though, on having adequate and accurate ground-based observations of snow depth and snow water equivalent. And one of the reasons that we do mention this so much during the winter is because this information is used, and it needs to be as accurate as possible for them to be able to successfully use this in their model and to project those types of parameters that they generate there. Let's take an example. Let's say we have a situation with a rain-snow mix where temperatures are near freezing, and because of that area, the model can't accurately determine whether the precipitation was a mix, just rain, freezing rain, sleet, snow. The model may indicate snow, but when they look at the observations, it may suggest that mostly rain fell. In that case, the model would be adjusted to match the observations. In fact, here's a statement that was on their site yesterday about the model adjustments. And this is on there when they do adjust the model. It says that that a data assimilation, or they actually used the OBS to modify the model, was performed for the Southern Rockies and Central High Plains. And you can see those are significant. 1 inch of water added to the snowpack in higher elevations in southern Wyoming, Colorado, and northern New Mexico. 1/2 to 3/4 of an inch of water removed at lower elevations. And out in the west, where water supplies during the spring, summer, and fall are very much dependent on snowpack the previous winter, these are significant numbers. So the observations that you enter every day as part of CoCoRaHS help calibrate these things and help make these products better and hopefully make decisions better. Interesting statistic is that CoCoRaHS observers really do provide a significant source of these data, as much as 40 to 50% of the total number of observations. Now that number is almost a year and a half old, so that is probably even higher. But think about it. Out of all the observations in the country that go into snowfall observations that go into no risk for their models, 40 to 50% are CoCoRaHS. That's significant. The data is publicly available. You can even see your observations along with all this other stuff at their website, and I have the link right here. It's www.nohrsc.noaa.gov, and this is what their homepage looks like. One of the things I'll show real quickly here is an example of what CoCoRaHS data looks like on their site. This is a CoCoRaHS station from New Jersey back in January of 2011. During the week they had a 18-inch snowfall, one of the blizzards back then. And this is one of 8 charts that appear on the page that when you pull it up. And the dots here are the actual observations that the observer reported. Both the blue dots here, the light blue and the purple crosses, and the lines are what the model is saying. And you can see there's an offset there. The model's underestimating some things here, but when it actually comes to the storm, if you look at the offset, the model actually did pretty well in simulating the amount of snowfall that fell, especially the change here. Here are the observations that the observer actually entered. And so you can see this. You can see what the model says. You can see your observations. And it has a complete description. You can search for your station on the website, and you can have a lot of fun. You can waste some time on that website, especially if you're a snow fan and you want to look at some of this information. But this is used, and every CoCoRaHS observation that they ingest has information like this as well. And you can also pull the data out in tables. So if you're proficient in a spreadsheet, you want to keep it, you can do that as well and look at the model data versus your data. Another use of precipitation data and temperature data is in drought monitoring. Drought's been a big story here in the country for the last 8 months or so. The average annual cost of drought in the U.S. has been estimated as high as $6 to $8 billion. We're talking a lot of billions this seminar. I mean, we're talking almost every number we've been talking about billions, not millions. So we're talking some significant dollars here. Back, about 10, 15 years ago, it was definitely known that there was a need to accurately depict drought in a simple, consistent, and comparable manner, so that you could look at a drought from this year and look at last year or the year before, and be able to tell people relatively what was going on. So back about 12 years ago, the U.S. Drought Monitor was developed. It uses a wide range of data: climate, weather data, water data, obviously stream flows, lake levels, and input from more than 250 experts around the country. It is sort of a mix of art and science, very much science, but there is a lot of ground truthing in here. And it's not just run a model and plot stuff on a map. So a lot of what you see here is based not just on data, but also on expert interpretation. The interesting thing about this, and right now we are really in a serious situation with drought around the country, partly because of the persistence of drought in the Southwest, and you can see it's been pretty bad in the Southeast, and it's now developing across the upper Midwest, is that about, as of this map, about 57% of the country was in a severe to exceptional drought category, or I'm sorry, was in, severe to exceptional drought. About 18% is in the extreme to exceptional category, the reds. So that's a big number when half the country is being affected by drought. So so 57% of the contiguous U.S. currently affected is a big number, and that's probably not going to change a whole lot before spring. What's the big impact besides water resources? Agriculture. We're talking a lot of cotton, a lot of wheat in Texas, Oklahoma, and Kansas. We're already seeing the dryness up here in the upper Midwest. So it's going to have some big impacts around the country, and we're going to be talking, again, big numbers. But again, CoCoRaHS observers had thousands of precipitation observations that are used to develop something like this, and a lot of the indices and parameters that they look at to develop the drought monitor. There's another way you can be more directly involved, just besides providing your precipitation, is the Drought Impact Reporter. It's a comprehensive database of drought impacts. It's submitted by state and federal agencies, the media, the public, and CoCoRaHS observers. You may, if you're new to CoCoRaHS, you may not be aware of this, but if you've been in CoCoRaHS for a year or two, you probably may be aware that CoCoRaHS observers can submit drought impacts reports through the website, and these reports provide ground truth on the impacts of drought, whether it's a stream drying up, a lake, or and you can assign some cost to it. But on this part of this issue of the Drought Reporter, which is from August to November of last year, you can see on the bottom that 29 of the reports, the impact reports, came from CoCoRaHS observers. So that's pretty significant, and I'm guessing a lot of those came from Texas and the Southwest. But that is one way that CoCoRaHS data, or CoCoRaHS observers, can be input into a very important national product, such as the Drought Monitor and the Drought Impact Reporter. This is the form that you'll see if you pull up the Drought Impact form on the website. It's much longer than this. I just gave you the top part of it. But if you haven't had a chance to look at it, pull it up at some time when you have a little time and take a look. With 57% of the country being affected by drought at this point, most of us probably have something to look at, or at least be aware of it as far as drought's concerned. Another area where weather climate data is used, and this is getting a little away from CoCoRaHS now, is retail sales. And this might seem somewhat logical, may not be. Weather shapes consumers' spending habits, obviously. You always hear, especially December, the weather's bad in the Midwest and Northeast, for example, snow, cold, retail sales decline. Retailers get nervous because they may not make their Christmas sales. Those types of things are in the news a lot, but there's some more subtle things that happen behind the scenes as well. Stores use weather data and historical trends and forecasts to determine what they need to have in stock, when they need to have it available, and how much they might need. Sort of a quick example of a forecast, or for example, if during hurricane season, the home improvement stores probably pre-position or actually have plywood available or ready to go to those areas in the southeast and along the Gulf Coast that might end up getting hit by a hurricane. It would be easier to pre-position that and make plans to do that ahead of time. And when the forecast indicates that, they can mobilize things and move it. According to the British Retail Consortium, weather is the second largest influence on the public spending patterns of Great Britain. It's second only to the economy. I would imagine, I couldn't find anything for the U.S., but I can imagine that it's not much different. Weather is a big influence. And if you think it doesn't take a lot of thinking to figure out why it might happen. Here's an example of how, a little more subtle way, a retailer might use weather data. A supermarket uses, and this is an actual example, they use sophisticated software. They plot sales information for individual products against past weather data, and that might be temperature, could be humidity, could be sunshine, could be a number of things. And then by cross-referencing these data sets, they can identify patterns and trends in customer spending depending on the weather. Here's sort of a very basic, simple example that, if they do it right, they can save millions a year. Data might show that when the temperature for a particular area rises above 70 for 2 or more consecutive days in the spring, sales of ground beef rise 35 to 40% because people start to grill out. If a retailer knows that ahead of time, that can save them a lot of money. That can make them a lot of money because they can be ready for that type of thing. So a lot of these analyses are done. We don't always are aware of all the very granular detail of all of them, but this is an example of how that kind of information might be used. And it takes a lot of analysis to come up with that, and you need the sales data and everything else. So companies spend money to get this type of thing done. Now, energy is where we really see a lot of use of climate and weather data, and that sort of goes without saying. It's been that way a long time. Historical weather data is used by utilities and energy suppliers to monitor supplies, to make sure they have enough for distribution. Weather forecasts are used to determine whether or not they're going to have a problem with the severe weather. But the energy industry has been using weather data forever. Forecasts are used to reduce risk, manage supplies, maximize revenue. A lot of energy sectors are spending money and investing in long-range forecasting techniques to give them a heads up on seasonal trends. If you knew back in November definitely that this was going to be such a warm winter in much of the U.S., you could have really positioned yourself to save a lot of money and possibly make a lot of money, depending on what your position was. For example, heating oil deliveries are based on the accumulation of heating degree days. Now, I'm sure everybody's heard this term. Not everybody's probably clear on exactly what it is. But what a heating degree day is an index. It's not an actual day. It's not an actual degree. It's an index. It's a cumulative measure of the departure of the daily mean temperature from a base temperature, and it's usually 65, and which is supposed to represent the heating demand. We're going to look at this in a little more detail here. You, as a homeowner or as an apartment renter or as an individual, can use this information to determine weather-related heating and cooling costs. If you insulate your attic, add new windows, weather strip all of your doors, you could actually use this kind of information to see if you've actually saved energy and if you've made a big investment, what your payback period might be on those types of improvements. So here's an example of how typical example of how a heating oil distributor might use degree days. Let's say you live in the Northeast and you heat with oil and your tank holds 500 gallons of heating oil. Now, based on your usage history, which the retailer keeps track of, the retailer knows that you're going to use 500 gallons when you've been accumulated about 1,200 heating degree days. So by monitoring the temperature each day and calculating the heating degree days for each day, he could know when you get close to 500 and schedule a delivery before your supply gets too low. And it's not based on a time schedule, it's based on weather, the temperature. So if you accumulate those 1,200 heating degree days over 2 weeks, which would be really bad, you would hopefully get your delivery in that 2 weeks, but if it took you 6 weeks to accumulate that, you wouldn't be getting a delivery for that 6-week period. Now, we're going to look at a quick example here on how you could use heating degree days to determine weatherization, if weatherization improvements have made, for example, a difference in your home's energy efficiency. Now, this is going to be a fairly simple example, just so we can keep it fast and simple, but the only things you need are information that's commonly available on your utility bill, heating degree day statistics, and the ability to do simple arithmetic. Spreadsheet works really good for this stuff. So this example is only going to assume that we use natural gas for heating and heating only. You might use it for cooking, but that's usually not significant in terms of related to your heating. But this way we know that the proportion of our total energy use is for home heating. This gets a little more complicated if you're, for example, an all-electric home or something, but it still can be done. It just takes a little bit more. So how do we do this? First, we look at what do we build on in terms of our gas. Most gas is built in therms, which is 100,000 BTUs or 100 cubic feet. That could be either of these other two as well, but assume it now it's a therm. So you find out how much gas you use during a billing period, and those are usually not 30 days. They're some odd amounts typically off. So you find what the period is. You sum the number of heating degree units, and I'm going to call them units right now because days gets confusing. These are not really days. This doesn't refer to a calendar day or anything else. So the way you calculate it is you take the average temperature for the day, which is the max temp plus the min temp, divided by 2, and then subtract that from 65. That gives you your total heating degree units for that day. So if our max temp today is 40 and our min is 20, then our mean would be 40 plus 20 divided by 2, which is 30. And we'd subtract that from 65, and we would have 35 heating degree days for today. So it's an index. It's basically an index of how much, supposedly, how much heating we would need. So once you accumulate those over the period of your billing, you divide your gas consumption by the number of heating degree units, and then you get a unit which is basically therms per heating degree unit or heating degree day. All things being equal, this should be a fairly constant number from month to month, this therms per heating degree unit. And by monitoring this number, you can see if you've made any improvements. And we're going to actually show an example here. Now here's what heating degree days are in case you're a little perplexed by this, and this does get confusing. This is actually February data from here at the Champaign, Urbana, where I'm at. And these are our max temperature and min temperature, the mean temperature for the day, and the heating degree days. What this is subtract 44 from 65, and we get 21. So every day has some accumulation of heating degree days. The total for this first 15 days of February is 489. So that's how you calculate, and then you accumulate the heating degree days. Typically we accumulate those through a season or for a month or whatever. But that's how you would calculate a heating degree day. So let's take an example. Just before last winter, the Weatherall family added insulation to their attic. So how much energy are they saving? They have records of their gas consumption. So in the 2 years before, they used a total of a little over 1,400 therms of gas. And they totaled up all their heating degree days from the climate data, and it showed that they used about almost 9,000 heating degree day units. So you divide the number of therms by the number of heating degree days, and you get about 0.16 therm per heating degree day. So that for every heating degree that occurred, they used a 0.16 therm of gas. So they insulated their house, and they recalculated things for the last year. Last year, they used 566 therms of gas, and there were 4,787 heating degree days. So you do the calculation, and it shows that they only used 0.12 therm per heating degree day. So they used less gas per heating degree day after insulating than before insulating. So by adding insulation, they increased their efficiency by about 25%. And had they not insulated, they would have used 766 therms and would have spent another $120. So you can see there's sort of, it's a fairly simple calculation, but you can actually figure out whether or not you actually save money on that type of thing. Now, in reality, other factors determine the amount of energy for home heating in addition to temperature. Windy days actually cause more air infiltration, and that may actually cause you to use more heat. So in windy locations, you might have to make some adjustment. And if your house has a good southern exposure, sunshine actually helps, so you might use a little less heating. But generally, you want to get a trend over a couple of years. So it is a good way to monitor your energy usage, and it's fairly easy to do. And you can use weather data from a nearby location that has maximum temperature and calculate it. It should be fairly good. A good online resource to learn more about this and how to calculate it is this link here, www.degreedays.net. So take a look at that if you're really interested there. I guess, I don't know, Henry, do we want to take a pause for a question here at all, or?
Why don't we keep going, Steve?
Okay, we'll do that, because
we're
close to winding up here.
Yeah, and then we'll have questions. So folks, if you'll hold off for another couple of minutes when Steve's finished, and you'll type in your questions, we'll take time to answer them then.
Okay, will do. All right, a couple more sectors, and these will go fairly quickly. Legal and insurance industry use weather data all the time. We get calls here at the Climate Center from attorneys requesting historical weather data to determine conditions at the time of personal injuries, whether it's a traffic accident, somebody who slipped on ice somewhere, or excuse me, or something else similar. That happens quite often. Past weather data is used in contractual disputes. For example, snow plowing. Most snow plowing contracts, at least in ones I'm familiar with, once there's 2 inches of snow, that's when they have to plow. Well, if you're right around 2 inches and somebody doesn't plow, or they do plow and it wasn't 2 inches, those who contracted the services might dispute whether or not they should have had or not had the service. So weather data is used to help resolve those types of things. And that includes also landscapers and anybody who's working outdoors especially, and is doing some activity tied to a weather event. We get frequent calls from insurance companies that want historical weather data to validate or invalidate claims. Hail calls are extremely common. Problem with hail is we don't have a lot of measurements. CoCoRaHS folks, though we do use CoCoRaHS hail reports to see if hail was in an area. Those reports are used, and if we find hail in an area that CoCoRaHS reported that we can't find any other evidence of, we do tell insurance companies. We say, we do have a report from a reserver in this area that reported hail, and this is what they said, and this is when it occurred. And we can sometimes verify that with radar images and other things, but those reports are used, and they're not just for general interest to see who had the biggest hail, but they are used. And same things with thunderstorms with lightning or heavy winds, or did heavy rain cause flooding of a street, or there's a lot of things that, anything weather related, obviously insurance companies may call us to verify or validate. And very often they're looking at fraud too. People try and claim things that didn't happen, and You know, somebody's claiming hail damage, and it turns out it was a sunny day when they're claiming they had hail, then we can sometimes help them with that. We get calls from law enforcement that wants historical weather data to use in criminal investigations. You know, they might call, was there snow on the ground? Because somebody said they saw footprints leading away in the snow. I had a call not long ago from one of the conservation officers here in Illinois trying to verify weather on a day that a photo was taken because he was trying to prosecute a poaching case. So a whole variety of things that could be used in the legal and insurance industries. In agriculture, it's sort of obviously tied to the weather. And similar to heating degree days, we have growing degree days and pest degree days to help manage crops and monitor the development of insect pests. A corn growing degree day is calculated in a manner similar to the heating degree days. There's a base temperature, but it's tied to the physiology of the corn plant. So it max any temperature above 85 above 86 is set to 86. Any min temp below 50 is set to 50, and the growing degree days, the amount of what we call corn growing degree days, are calculated. And the faster these growing degree days accumulate, basically the sooner the crop would reach maturity. Colder weather means they will accumulate slower, which means the crop would mature later. Obviously, precipitation and temperature are important with soil moisture and soil temperature. Too much precip in the spring can delay spring planting and or cause a seed to rot in the field. Out in the plain states where irrigated agriculture is very much dominant, weather data, including precipitation, is used to track water usage and schedule irrigation for crops. And how much irrigation you need depends on how much precipitation you've had, how much might be expected, what the soil conditions are. High Plains Regional Climate Center has an irrigation tool. You go online and it pulls in weather data and other information about your particular farm that you can use to decide what your irrigation schedule could be. That's another practical application of the daily data. In engineering, weather data is used in building design of stormwater retention projects, reservoirs, dams, structures, heating and cooling, obviously ventilation for large buildings. Accurate precipitation data is needed for drainage-related issues, whether it's floodways, stormwater management, wetlands, modifications to floodplains, or even claims for flood damage. We've had a civil engineer that locally that uses CoCoRaHS data quite a bit to help resolve flood claims. And very often our precipitation observations, we all know how variable precipitation can be, and that even with the basic network, we don't have always observations where we need them. But the more we have in terms of like CoCoRaHS, where we have a large density of observations in some areas, as he said here, he can find CoCoRaHS information within blocks of a location that he's interested in. And he can look back at the record of that particular station and observer and see if they're consistent, and he can use that data to help resolve some of the questions that he has as a civil engineer trying to either verify flood damage or even working on flood modification. Transportation and shipping obviously use quite a bit of weather and data. Forecast data is used quite a bit, especially when you're routing trucks across the country. You want to avoid obviously areas where there are going to be delays, airports using weather forecast data all the time. Manufacturers use weather data to schedule shipments in their production of their products, whatever that may be, because some of them are environmentally sensitive and will depend on temperature and humidity, and they will monitor that and sometimes contract for forecasts to help them minimize their risk. But obviously transportation is a big part, and the aviation industry in particular uses weather information all the time. Another interesting area is tourism and recreation. other than the obvious, if it's nice outside, you want to go somewhere, tourism industry has begun using weather derivatives, which developed in the energy industry, to both protect risk and then help market destinations. Now, weather derivatives can be somewhat of a complex concept here, but basically they pay a fixed amount based on observed weather conditions. In marketing it right now. But here's an example of what we're talking about on how they might be used. The island Barbados wants to make sure they're protected against low temperatures and heavy rain, because you don't go to Barbados for rain and cold weather. So it gives travelers money back when the daytime temperatures do not reach 79 or when there's more than 2/10 of an inch of rain. And so it's also a marketing thing. So they're saying, yeah, come on, well, if it's this bad, we'll give you some money back. And people are willing to take that risk. Bombardier Motor Corporation, which makes new snowmobiles, promised buyers of new snowmobiles that if there's snowfall in their area was less than 50% of a 3-year average, they'd get a set payment. And I think I've seen those even down here for some promotions for snow throwers and even other things. And then Priceline, which you're probably all aware of from TV commercials, they offer to consumers a sunshine guarantee that refunded travelers if it rained more than a ½ inch per day during half their days. Now, they know what the risk is with this. They have the statistics that say that this is at odds of X amount, has X% chance of happening. So they are basically protecting themselves, but they know what the risk is. And you know, if it never happens, they're fine. And if it does, they probably will make it up, because they will attract more people to do it, because the people are willing to take that risk of getting refunded rather than just canceling altogether. And again, another simple use of it, the Southeast Regional Climate Data plotted temperature data versus zoo attendance to help the North Carolina Zoo try and determine how weather affects their visitors throughout the year. Basically, they found out that as attendance increases with temperature in the cool season, and basically the hotter it got in the warm season, the lower the attendance. Not an illogical relationship. And in human health, we all are aware of how much extreme heat and cold can affect us, but always a problem has been, what is a weather-related death? How many steps removed from the weather event do you can attribute to a weather-related death? And this is actually a fairly new area that's being ventured into, is relation between human health and weather is actually being looked at a lot more. One approach has been to study the influence of weather and climate on disease vectors, such as the mosquito that causes West Nile virus. Some work we've done here in Illinois to develop a simple model that basically predicts when the mosquito that transmits West Nile virus is going to become dominant, and therefore your risk of being bit by that mosquito and possibly getting West Nile is higher. Very simple relationship, and it's a simple concept. The relationship isn't quite as simple as that, but that's the type of thing that we're looking at in terms of weather data and human health. So in summary, basically all sectors of the economy are impacted by the weather. $1 trillion a year exposed in the U.S., and our actual costs, incurred costs, may be as much as $485 and even higher annually when you add the weather disasters. It makes a lot of sense to use weather data to manage your risk, increase your competitiveness, and more businesses are doing it every day. The Weather Service, of course, their main mission is to protect lives and property, and that's what their forecasts are geared toward. And forecasts also help guide business decisions. Historical weather data, such as what becomes yours after 5 years in CoCoRaHS, can be used to determine trends, correlate with other activities, whether it's in retail or energy, and knowing how the weather in the past has impacted activities allows you to use that information and forecasts or projections to predict impacts on future activities. And this last graph here is a chart of the precipitation in Ballinger, Texas since June 1st of last year. The line at the top, the brown line, is the normal precip, and the green is the accumulated precip since June 1st. You can see how dire the situation there is in Texas. So that's it, and I'll be happy to take any questions.
Thank you, Steve. We really appreciate your time today in presenting that information. Very informative. Folks out there, if you have any questions right now, if you go ahead and type them in, and we'll try to get as many. We're at the top of the hour right now, so we'll probably stay on about an extra 15, 20 minutes. We'll try to answer as many as we can. If we don't get to your question, Steve will try to answer it through email within the next week or so. We'll have that. So I've got a question right here, Steve,
Okay.
from David, New Hampshire, and he wants to know, what is the official number of years used to calculate daily averages of temperature, precip, etc.?
The number of years is 30. The averages change every 10 years. So right now we're using the 1981 to 2000 data to calculate average temperature precipitation. That's all the official normals are being calculated from that period.
Great. Here's another one from Gregory. He wants to know, how do you determine that you are in drought?
That's always been a very good question. Drought is largely defined by its impacts. A meteorological drought is when precipitation has been below normal for an extended period of time, and you can set your definition there. But if normal precipitation in the desert's 0.3 of an inch and you only get 1/10, is that a drought? Well, probably is meteorologically, but in the desert it probably doesn't make a darn bit of difference. So it's not really, the impacts aren't there. Whereas in the middle of Ohio or Texas or Ohio, Indiana, or Illinois, during the spring season, if rainfall is only 60% of normal, and you're getting over half the rainfall, which is not a small amount of rain, that's probably, you're getting into a drought, because that is significant and is probably having impacts on water supplies over the long term and on agriculture. So the definition of drought varies, but it largely is defined by its impacts.
Okay, Steve, here's an interesting question from James in Maine. He wants to know, as a climatologist, how do you approach a politician who remains skeptical regarding man-induced climate change?
Well, the easy answer to that is I don't. No, climate change, climate has always been changing. Unfortunately, the whole issue has gotten extremely politicized and has shaded everything, and the politics of it has shaded everything else. But climate is always changing. We went through a huge drought, heat waves in the 30s and again in the 50s, and those are still events of record. We haven't surpassed those yet. But the climate has changed somewhat since then. We haven't experienced that again. Can we experience it again? Certainly. It's certainly within the realm. It's happened before. It certainly could happen again. My approach would be that climate change is always changing, and whether or not the climate's going to warm by a degree or 10 degrees, we should be good stewards of the planet and be mindful of that. But also, we always have to be adapting to climate. Whether or not you think it's changing 1 degree or 5 degrees, it is going to have some effect on what we do, and you need to be aware of that and be adapting.
Great. Here's Bobby, who writes, do sports teams or sporting places use water data?
Water data. In terms of precipitation, they use, I'm sure they do, golf courses, for example, are very cognizant of rainfall and how much they need the water to keep their fairways green and their greens green. Sporting venues such as the stadiums, large sporting events, a lot of them employ private weather forecasting firms to keep them apprised of weather situations. Baseball, a good example. We're coming into baseball season here. A lot of them will employ a weather firm to keep them apprised of approaching rain, or if rain is approaching, how long is it going to last? Do they need to call the game? Do they need to make other adjustments? So sporting venues use weather data and weather forecasts quite a bit. Historical weather data they might use to do some planning, but in general, I don't know if they use it on a day-to-day basis like that.
Okay, thanks. Let's see, we have another one here. Okay. Larry in Kansas wants to know, is the general precipitation pattern for different parts of the U.S. increasing or decreasing, and is that change a cyclical event?
Okay. Yeah, that's a tough one. I don't know that answer offhand. The one thing about the weather is, even with climate change, well, you wouldn't think about climate change. If you talk about warming in general, everything doesn't happen the same way everywhere else. If it's warming in the western U.S. X amount, it doesn't mean it's warming in the east that same amount, or in the central U.S. So there are differences regionally, and quite a bit of difference regionally. One thing we do know is that the incidence of heavy rain events have been increasing in the United States. And we're talking about those events that will be, let's see, for example, the heavy rain events over an inch or 2 inches, the ones that tend to cause urban flooding, urban street flooding, or some of the spring flooding that we've had. Though the bigger events seem to be occurring more often. Overall trend, I haven't actually looked at the new averages to see how they compare to the old. The decade of the 90s was very wet in, for example, the central U.S. So, but I don't believe the 2000s were quite as wet. So we might have actually seen a decrease in the trend there. So you have to look at it very closely. Yeah.
From the statistics, this is Nolan chiming in.
Chime in.
Some of the northern plains, the Dakotas, the Red River Valley of the North, there's definitely evidence of a long-term trend, or at least going into a wet cycle, that we've been in a wet cycle. Likewise for New England, but like you said, not all the country does the same thing at the same time. Southwestern states have shown a bit of a drying trend at the same time that the northern plains and New England have a bit of a wetting trend.
Yeah. Yeah, I had forgotten about the northern plains there, but that's a big concern because of Devil's Lake and the Red River of the North. Those types of things are more long-term climatological things. So there are different trends, and they are different in different parts of the country.
Okay, we've got a lot of questions out there, so we're going to try to get through some of these. And again, if we don't answer your question, we'll try to follow up with an email from you. Bob from Illinois writes that given all the observation data modifications to precipitation model forecasts, he wants to know, am I naive to think that the forecasting models are finely tuned and thus more accurate than ever?
Okay. Read that again.
Sure, let me go back through it. Given all the observation data modifications to precipitation model forecasts, am I naive to think that the forecasting models are finely tuned and thus more accurate than ever?
Probably, well, more accurate than ever. Probably, yes. They're probably as accurate as they've ever been, but how accurate is that? Now, I assume we're talking about precip amount. I'm not sure. Or
yeah, I'm not sure from the question.
But in terms of precipitation amount, there's still an element of human interaction that goes into that. But yes, the models have gotten rather sophisticated, and they probably are better than they've ever been. But is there room for improvement? Sure, there's plenty of room for improvement. Precipitation varies so drastically over such small areas that probably ever getting it down to the point where you can be even 90% perfect is probably not reasonable in the near future, but they certainly are a lot better than they used to be, and I think generally the confidence is fairly high in most of the model forecasts, but it depends on the situation and on the model. That's why we don't just use one model in forecasting. We look at a variety of things because some models have strengths in some areas and some have weaknesses.
Okay, John from Illinois writes that he wants to know if there's a website available to determine what basin area by location is included within.
Yeah, I believe if you would go to the Weather Service website, and I don't know where in Illinois you are, so it'd either be Chicago, Quad Cities, Lincoln, St. Louis, or Paducah, if you go to their hydrological tab on their page, I think you can find out there what basin you're in. And I will double check that, and if you want to drop me a note, I'll see if I can follow up with that further. But I believe you can find that on the Weather Service website.
And Henry, this is Nolan. Watershed mapping is something we're planning for CoCoRaHS in the future. Probably not this calendar year, but hopefully next year, where you'll actually be able to see your data and know what watershed you're in.
Thanks, Nolan. You know, we've got a couple questions here concerning CoCoRaHS stuff as well, so feel free to chime in along with Steve on these. And actually, Cindy from Missouri writes, how does CoCoRaHS help the local weather channels? Either one of you guys.
The local weather channel. If you're talking about your local TV stations?
I think that's what she's referring to.
I would say that's probably up to each particular TV station, whether or not they certainly have access to the data. And I would be surprised if they're not looking at it. But many TV stations have their own little network of observers, or they have their own little promotion that they do, and they may not acknowledge or promote CoCoRaHS as readily as some others. But I would hazard to guess that they know the data is out there, and they're looking at it because it's valuable data, and it's precipitation data they wouldn't otherwise have.
And not sure what part of Missouri you're from, but the Springfield, Missouri area TV station there has a long history of promoting CoCoRaHS and utilizing the data on a very regular basis. But it varies, like Steve says, from station to station and region to region.
Okay, here's a question. How does the current Texas drought compare to the droughts in the Southwest during the Dust Bowl years of the 1930s?
Nolan?
Yeah, I followed that a little closer. It's closer to our region here. As an individual year, 2011 was, for many, not all, but many parts of Texas, was the driest individual year in recorded history. However, Texas had a couple of long runs of dryness, both in the Dust Bowl year, especially in the Texas Panhandle, West Texas area, and then for quite a bit of Texas, the 1950s, 52 through 56, were just really bad. Not as any individual year as bad as 2011, but the cumulative effect would require that we'd have two more years like 2011, maybe not quite that severe, to equal that long-term effect of that 50s drought. So there are some big droughts of the past that have occurred. And again, Texas is a big state, so when I generalize, it may not be true for all parts of the state.
Okay. Cheryl writes, do you see any effects from geoengineering or weather modification in weather forecasting?
In weather forecasting, I mean, there is weather modification activities taking place, and it's used in the mountainous areas. They use weather modification cloud seeding to help enhance snowfall and snowpack. I believe there's still some activities regarded to hail suppression and some in rainfall enhancement. As far as forecasting, though, I don't think there is much of an effect at all, because most of those events are fairly localized, and they don't even try and forecast things like those types of modifications because they are so localized, and really most of the forecasts are a much wider area.
And geoengineering is being talked about more and more now as a potential mitigation strategy to offset the increasing greenhouse gases in the atmosphere. But mostly that's just talk right now, very little actual action. And as Steve says, the main weather modification we actually see in the country and in a few parts of the world are fairly limited areas of mostly mountain cloud seeding, and then some Great Plains, Kansas, Texas, and North Dakota summer cloud seeding for hail suppression and rainfall enhancement.
Here's one from Stan in Missouri, and his city is giving away free weather radios. Wow, we have to head over there. That's pretty good. He's wondering, where do folks like this get funding or financing to do stuff like that? You guys, any?
That's a good question. I'm not sure. Some of that might The city's doing this. It might be, could possibly be Homeland Security. Could be the company that manufactures the radios has sometimes done that too. Either way, it's a great deal, and everybody should have a weather radio.
Yeah, I guess in response to probably to the tornadoes that have come through there recently, there's more of a need to or alertness about that. Okay, let's see. We've got a. Let me go back to another one here. Somebody asked if we would give the Norsk website again. If you could go back on the slides.
Oh, the Norsk? Sure.
Yeah.
I can do that. It is.
I guess it's the Snowdash stuff they were looking at. We can post these on the website as well, on the WxTalk website.
It's www.nohrsc, I'll get it up here in a second, .noaa.gov. It's right there. www.nohrsc.noaa.gov.
Here's a question, and from someone says, some parts of the country are covered very well by CoCoRaHS stations, others are not. Do you still want more observations for the areas which have the most coverage, or would that just lead to duplication?
I'll chime in here. And Steve, you do have some of the parts of the country that are nicely covered, as do we here in Colorado. In Fort Collins area alone, we have 60 to 80 volunteers that report in an area of about 150 square miles, and we treasure each and every one of those reports. We're not finding a problem anywhere of having too many reports. Nope. Of course, we would love to fill in some of the gaps where there are very few. But, of course, population is not uniformly distributed across the country, so we're not going to have the same potential for recruiting. But, yeah, we still are recruiting in areas even where there's a lot of volunteers, and there's good reason for that. Steve, how do you want to express that?
That's exactly right. I don't discourage anybody. In fact, I have somebody that lives within a quarter-mile of me and said, well, you're already over there. I said, that's fine. If I'm not reporting one day, you're the closest observation, and that helps fill in gaps. But yeah, my philosophy is you could never have too many observations.
Here's one from Greg in Colorado. He wants to know, has there been a ground truth of the CoCoRaHS data to get a general accuracy level? So are we ground truthing CoCoRaHS data?
Well, we're always comparing the data to the other sources that we have, which is predominantly in terms of having a high density of observations, would be the National Weather Service Cooperative Observer Network, with roughly one station every 20 to 25 miles across the country. Nationally, we have about the same number of stations reporting regularly in CoCoRaHS as there is in the National Weather Service Cooperative Network. But at our own station, here in Fort Collins, we've done side-by-side measurements for literally 14 years, and we find our National Weather Service observations and our CoCoRaHS observations generally within 3%. The National Climatic Data Center, a part of NOAA, has done some intercomparisons, and they find the reliability of CoCoRaHS data to be sound. Yes, on any given day, and those of you who watch our maps regularly will see some bad data points show up here and there, and we have somebody doing quality control on a regular basis to manage that. But yeah, the data are imperfect, but they're really not bad. They're usable. They're research quality in most cases.
I mean, the fact that they're imperfect, that's even true of the cooperative network. So any network out there doesn't have 100% perfect data, and so CoCoRaHS does extremely well in that regard. And like Nolan said, it's not just one person looking at the data every day. There's lots of eyes looking at the data every day to make sure that it's the best data that we can have.
And there is a perception that the fancy automated weather stations, the airport weather stations of the National Weather Service, plus home automated weather stations, just by virtue of being electronic, are going to be better. Studies continue to show that the most reliable measurement for a total climatological accumulation of precipitation is still what you get from a manual gauge.
Okay, we're going to take two more questions, and then the rest we'll try to answer off the air for time concerns here. So Tom writes, does CoCoRaHS assist with making crop rotation decisions?
Well, I'm not a farmer, and I would say that most crop rotation decisions are probably made based on more related to what was in the field, obviously, the year before, agricultural pests, i.e. insects, that might be a problem, and possibly soil nutrients. It might enter into it if they need to know how much precipitation has fallen over a particular field or group of or acreage, but in general, I think crop rotation is based more on what was there before, and why are we going to swap, for example, corn with soybeans, because last year there was corn there and we don't want the rootworms to be hitting the corn the second year, so we're going to plant soybeans.
Yes, on the western Great Plains where precipitation is very limited, there knowing the soil moisture, which is very important, especially for the winter wheat crop through the winter season, will sometimes have an effect on the decision of what to plant after the wheat is harvested. But often their decisions have to be made longer in advance because of the cost and order time for getting seed for large crop rotations.
Okay, guys, here's the last question of the day, and it's from Bill in Illinois. And the question is, what additional measurements might CoCoRaHS observers provide in the future? For example, freezing level, humidity, soil temperatures, etc. And I guess it's a great time to talk about our ET ventures that we've got going on this year. Nolan?
Yeah, we try to keep it simple with CoCoRaHS. There's so many things we could add, but adding adds complexity, and complexity sometimes scares away other participants. So we're going to try to keep it simple, focusing on precipitation, which we know is the variable that can vary the most over short distances. That being said, we are introducing the measurement of evapotranspiration. You'll be seeing that within the next month or two, which it's not going to be an instrument that just anybody is going to go and pick up, because they cost close to $200. But you've got one there in Illinois that you've been testing, right, Steve. We've got a few here in northern Colorado. We really like what we're seeing in terms of being able to get a first estimate of what is evaporating back up into the air from the precipitation that has fallen. So it's going to give us a shot at water balance. Yes, we encourage people to add additional information to the comments field, temperature, high winds, unusual weather events, etc. But one of the things we really are contemplating to quantify a little better in the near future will be the quantity of freezing rain, the accumulation of freezing rain. That's an element that is not observed, to my knowledge, very, very well by any other network, and CoCoRaHS observers would be really good at being able to go out and say, how thick is the ice on wires and branches after a freezing rain event?
Well, thank you, everyone, for sitting in on the webinar today. We really appreciate your time. And Steve, thank you for giving your presentation. We've learned a lot. And with that, we're going to sign off for today. So before you leave the webinar, take a look, and if you would fill out the evaluation. And then join us for our next webinar, which will be coming up on Thursday, March 8th at 1 p.m. Eastern Time. NOAA's Tom Schlatter will talk about understanding and identifying clouds. That sounds like a very interesting webinar. We'll have some stuff out on the message of the day on our website on how to sign up for that one shortly. So from the Colorado Climate Center, we wish you a good day and have a good afternoon.
The organizer has ended this